Did you hear me?
Yeah.
Okay, so is there like you posted the work on Google Classroom already, right? And are we going over anything new?
Yeah.
Well, it probably won't be that hard, so I'll just do the work in Google Classroom.
What do you mean? You
I
leave?
said the work you posted probably won't be that hard. Because I have an appointment.
You have an appointment?
At 3:15.
For what?
Doctor.
Okay. Well, I'm gonna record this lecture, so if you want to watch it later, you can.
Okay, thank you.
What was I gonna say? Julio had a soccer game on Saturday. Did y'all win? Did y'all win the soccer game on Saturday?
I don't play. You know what, Bob? I don't play soccer.
I'm not talking.
Tripping.
Why don't you play soccer?
I'm never gonna answer that question. You know I don't play soccer, miss.
I mean, you should play soccer if you want. Okay, so what we're gonna do is we are going to go over this PowerPoint that is called percent yield. We're gonna figure out what percent yield is. You guys are going to get a. Oh, you guys won 3-2-0. That's pretty good. That's actually really good. Next, just a reminder that you guys do have your assignments due. So a lot of people haven't been turning in assignments, and I know because of everything that's been going on. A lot of things happened last month. It's just too much, and we're forgetting to turn in our assignments. So if you guys haven't turned in your assignments, turn them in. And that's all I have to say. So I need everyone to join Nearpod if you can. There's not much we're gonna do today. I think it's this week. So join Nearpod. I am thinking about bringing my cat to school. You guys think it's okay with me bringing a cat to school? I feel more comfortable if I have my cat. I don't know. I can't figure out stop talking about cats. Okay, we got Adriana. I need more people to join their pod. We got 2 people. We got Maxine. So I need everyone to join in your pod. Ow. Okay, we got Julio, the Jade, Ariana, Maxine. We need at least 7 people. Right now we got 4. It doesn't want to load. Okay. Anyone else? 7 people we need. Juliana, join their pod. Daisy, Charlie, Anna, Amani, Aaron, join their pod. Okay. Okay, so we're gonna start. So what we're gonna go over is going to be theoretical and percent yield. And what you guys are going to do obviously you guys need to practice. So hopefully by the end of this, you guys will know the difference between actual and theoretical yield. And then we will use that to calculate percent yield. And then we're gonna go over what we've been doing before, which is calculating grams from grams using stoichiometry equations, which is the stuff we've been doing for about 3 weeks. So that's what we're gonna be doing today, which is basically the same thing we've been doing. Okay, so when you guys do an experiment, do you guys think every experiment is perfect? Yes or no? No. So like Jay says no. Juliana says no. Erin says no. Maxine says no. Ariana says no. And then you guys want to explain? Does anyone want to elaborate as to why you guys said no? Or I'll elaborate for you. So when I was in college, this is the only explanation I can say. No. So when I was in college, what we were graded on, we will have to do experiments like this, and then we will have to set it up like this. So you will have to set it up, and then you will have to get the Bunsen burner, and then you will have to like measure out how much you're gonna use, and then what your grade was is you are graded on how much product you get out. So your yield. So your yield is gonna be what you get out from the experiment, and that's what we were graded on. So whatever we got out at the end was what we were graded on. So if we messed up in our experiment and we didn't add enough grams, or we added the wrong amount of grams, and our Bunsen burner was too high, and everything we did wrong, our yield is going to be horribly wrong. So not all the time our experiments are going to be 100% perfect, because we are not perfect. I am not perfect. I don't even remember my grade. But yeah, so this is what we did in chemistry class. We will have to set up stuff like this. I'm not trying to go into that website, but that's what we did. Too bad we can't do one of those. But what do you guys think is the difference between theoretical and actual yield? So yield is what you get out. So yield is like if I did my experiment and I got a yield of 25 grams. So yield is my amount produced. My amount produced, that's a good way of putting it. My yield is my amount produced. But what do you guys think is the difference between theoretical yield, actual yield? Theoretical yield, actual yield. What do you guys think is the difference? Oh my goodness. My goodness. I'm sorry, guys. What do you guys think is the difference between actual and theoretical yield? I accidentally pressed the shut off button on my computer. If anyone wants to. Or tell me, just look it up. Look up, one's a theory and the other one's actual. Okay, yeah. That's exactly right. Concerned with or involving the theory of a subject or area of study rather than its practical application. Even legit, I don't even know what that means. Concerns with or involving the theory of a subject or an area of study rather than its practical application. Anyone else? I like blue. Theoretical will be what you expected and actual will be what you get. Yes. So yeah, so theoretical will be like if I did it 100% right without any mistakes, but usually that's never gonna happen. So theoretical will be what actually happened, like what you expect the reaction to happen. But if I was to actually do the experiment, I'm not a robot. And then we have a lot of external things happening. So maybe our equipment doesn't work, or maybe the fire is too much, we heat it up too long, the water is not distilling or something like that. That's the actual yield will be what we're gonna get out. So it will be what you actually get out. The actual yield is the quantity of a product that is obtained from a chemical reaction. In contrast, the calculated or theoretical yield is the amount of product that could be obtained from a reaction if all of the reaction, I think, is used. So that is true. So theoretical yield is the maximum amount calculated. So theoretical, you're not gonna come up with a theoretical yield because you can't. We're human. We make mistakes. I can't get theoretical yield out, but I can calculate the actual yield from doing the experiment. So it's gonna be the amount obtained when the reaction takes place. So when you guys do the experiment, the amount you get out is gonna be your actual yield. Theoretical will be, the maximum amount that you should have gotten out. So what you guys are gonna do is, you guys are gonna calculate percent yield. So percent yield is the percentage of how much you got out. So actual divided by theoretical times 100. So if I got, my actual yield was 75 grams and the max was 100 grams, I would do 75 divided by 100 times 100, and it will give me 75% yield, which isn't too bad. It's a C, but it's not the best. So percent yield is just a ratio. Okay, so calculating percent yield. Suppose you prepare cookie dough to make 5,000 cookies. The phone rings and you answer. While talking, a sheet of 12 cookies burns and you have to throw them out. The rest of the cookies are okay. What is the percent yield of edible cookies? So we're talking about percent yield of edible cookies. It says theoretical yield, 60 cookies possible. So where did they get the 60 cookies possible? Where did they get the number 60? 60 cookies possible. Where did they get that number from? Suppose you prepare cookie dough to make 5,000 cookies. The phone rings and you answer. While talking, a sheet of 12 cookies burns and you have to throw them out. The rest of the cookies are okay. Where did they get 60 cookies from? Where did they get 60? The formula. No, not from the formula. 5 dozen. So 5 dozen, it's 5 times 12. If you don't know what a dozen is, it's fine. I didn't even know what a dozen was until late in life. So 5 dozen cookies is 5 times 12, which is 60. And then that's the theoretical, so that's the maximum amount of cookies she could have made, because that's all she has. Actual yield is 48 cookies. Why is it 48 cookies? Why is the actual yield 48? What happened that it went from 60 to 48? What happened in the scenario? What did she do? Where did she mess up that now they have a yield of 48? 1,000 burned. 1,000, she was answering the phone and then she burned 12 cookies. So she had to throw them out. So we only have 40 cookies left. So 48 divided by 60 times 100, we got an 80% yield. Okay. Y'all think it's easy, but it's not. Okay, so I want you guys to calculate percent yield on number 1. So the formula is actual divided by theoretical times 100 equals percent yield. So that is the formula. And then try and figure out the answers to these questions. Isaac, what are we gonna do, Isaac? Here, you didn't even get this paper, here. You need to go to sleep? It's because of the way you were sleeping. You're just sleeping weird. I mean, you were using your mask as a whatchamacallit? Eye mask. You were putting your mask on top of your eyes so you won't get any light. Once we get 70% participation. We will continue. We got 50-50, 7% correct, 14%. No, that's not 50-50, is it? That's not 50-50. We got 20 to 50% incorrect. Actual divided by theoretical times 100. Okay. We got 21%, 21%. Huh? It's 50-50. Now majority correct, 21% incorrect. Number 2 is kind of tricky because they gave you the percent yield. So you have to go backwards. So you will have to, they will give you the percentage and you will have to move the decimal twice to the left. Or you can, I think, divide it by 100 and you will get the decimal. And then you will use that decimal to solve for theoretical. And then we'll go over how to do it. Isaac, what are you eating? Gummies. That's how I know y'all are in high school, because y'all bring gummies as food. Let me see. %43% have not answered, which is surprising. Okay. Aaron didn't answer. Amanda. But y'all it kind of, it's fine. So to do number 1, all you had to do was figure out which one was the actual and which one was the theoretical one. Actual, they gave you which, they gave you the definite, they basically told you the answer. All you had to do was know the formula, which is 62 divided by 73, actual divided by theoretical times 100, and the answer would have been 85. The next one, they gave you 80%, so that was the answer. Well, that was the percent yield, which is the thing you get out. They give you this. The formula is this, but you have to solve for x. So the thing I would have done is, let me do 80. I would have done 80 divided by 100. And once I do that, that cancels out. I get 29.1x equals 0.80. And then I will switch these two. I will get 29.1 divided by 0.8. And then I will get the answer, and it's going to be 63.3. So this is like math kind of stuff. So I don't expect you guys to get it because we're just going over it. But those were the answers. Yeah. Okay, you guys can get off NARPod now. You guys don't have to be on it. That was it. That was it for NARPod. You guys don't have to be on it. Okay, so what we're gonna do is the questions that you are given aren't really the questions that we just did aren't really what gonna be on the homework. On the homework, you guys are gonna have to calculate the yield, and then you guys are gonna have to figure out which one is which. So this question that we're going over right now is gonna be a question similar that's gonna be on the homework. And then we'll go over what this question is. So it says without proper ventilation and limited oxygen, the reaction of carbon and oxygen produces carbon monoxide. What is the percent yield if 40.0 grams of CO is produced when 30 grams of O2 is used? So it says, so we're solving for percent yield, which is what we just did. They give us 40 grams of this, and they gave us 30 grams of oxygen. Which one do you guys think we're gonna use? Are we gonna use the 40 or are we gonna use the 30? So we're gonna have to use one of these numbers. Which one do you guys think we're going to use? It says, what is the percent yield if 40 grams of carbon monoxide is produced when 30 grams of O2 is used? So we are going to use the 30 grams. So the 40 grams, is this going to be actual or is this theoretical? So is 40 grams going to be actual or theoretical? It is actual. So when they did this reaction, they did the reaction and then they got 40 grams of CO out. So they made 40 grams of this, of the product. They used 30 grams of oxygen. But this is going to be the actual. You're going to use the same amount to calculate the theoretical because this was not a perfect reaction. So that is what we're going to do. So this is what I'm going to do. 2C plus O2, 2CO. This is my reaction, and then 30.0 grams of O2. Before we start, do you guys know what molar mass is? What is molar mass? The definition, or just like a quick idea what molar mass is? What is molar mass? Because every single time I ask what's molar, like I ask you guys, find out molar mass or something. I don't feel like majority of people know what it is. So does anyone know what molar mass is? Okay, like quickly explain it in words that your other classmates can understand. Because I feel like I don't explain it very well. Oh, we got someone. As the mass of a sample of that compound divided by the amount of substance in that sample measured in moles. I feel like that's more complicated than I wanted. Molar mass is the weight of a compound or element found in the periodic table with a unit of grams divided by mole. So that's the definition of molar mass. So whenever I ask you guys for molar mass, I will have to go to the periodic table and calculate it. So I can't just come up with a random number. Okay. So in the first box, I'm gonna draw this black because we're not gonna use it. What do you guys think where I'm gonna put in the first box? So in the first box, you always write something. What are we going to write in the first box? I'm just gonna given. So the given is 30 grams. 30 grams of oxygen. So we're talking about this. So if I was going to do this reaction, they gave me, I'm starting with 30 grams of oxygen, and I'm trying to figure out how many grams of this is going to come out, because that's what we're trying to do. Kind of like a recipe. Okay, next, I'm going to figure out the molar mass, because I have to cancel out those grams of oxygen. So when I put it in the bottom, this line, that horizontal line that goes through the entire thing means that you're dividing. So it's like a really big fraction. So this line means dividing, and then these lines means you're multiplying them. So when I put it in the bottom, it's going to cancel out because everything you put on top and the bottom and you divide it, it cancels out. So I'm going to put grams of O2 in the bottom, it matches. But where am I going to get the grams of O2 if I'm talking about the molar mass? And I just said the molar mass is the weight of a compound of element found in the periodic table with the unit of grams divided by mole. Where would I find the mass of the oxygen? Where do I have to go to find the molar mass? The molar mass of oxygen. Ooh, we got someone. O2, yeah, the mass of the mass of O2. So we have 2 oxygens, and I'm gonna say that the weight of oxygen is 16, and I got that from the periodic table. So I'm gonna multiply them, and I'm gonna get 32 grams divided by mole. And this can be written like this, or it can be written like this. So what do you guys think I'm gonna put here? In the box where I drew the star at. No, we're actually not going to write one there. The grams, which is 32. So I'm gonna write 32 grams of oxygen. And then what am I going to write on top? So this is molar mass. The unit for molar mass is this. 1 mole. Okay. So if you don't know what molar mass is, it's like if I was trying to figure out the weight on my calculator, I obviously only have one calculator. So that's saying my calculator weighs 18 grams. I only have one calculator. So if I wanted to say 1 mole, it's like I'm talking about one singular element. It's like I'm talking about how many I have. So if I say 2 moles, then I will have 2 calculators, but I only have 1. And it's saying the 1 mole of oxygen will weigh 32. So it's saying you have 1 oxygen, it weighs 32 grams. I hope that, I don't know if I'm explaining it very well. So what I'm gonna do next is I gotta cancel this mole of O2. So I'm going to write it at the bottom. So remember that every single time you write it on the bottom and you have it on top, they cancel out. But I don't have anything, I don't know what, because I want to convert the oxygens to CO, because that's what I'm trying to solve for, I'm going to use the mole ratio. So how many moles of oxygen do we have in our mole ratio? And the mole ratio, we get it from the formula. So this is our formula, and we're talking about the numbers that I just circled. So the mole ratio is the coefficient, and coefficients are the big numbers in front of the elements. So we're not talking about the little numbers, we're talking about the big numbers. So what is gonna be the mole ratio of oxygen? And someone told me the answer. It is 1. Thank you. 1. And like I said, we're trying to go to CO because that's what we're trying to solve for. So I'm gonna do mole of CO because we're converting the grams of oxygen to CO because we're trying to figure out how much we have. How many moles of CO we have? Wait. 2. And then the very last thing is we have to cancel out the moles of oxygen. I mean, the moles of CO. I'm going to put that in the bottom. And when I put it in the bottom, it cancels out. And then I'm solving for grams of CO. So because I have the unit grams divided by mole, we're talking about molar mass. What do you guys think I'm going to put in the bottom? If this are the same thing, one mole. Oh. 1 mole of CO. And then the molar mass in the unit grams, whenever you see G, it means grams. So we're talking about how much does it weigh. Grams is the unit they use to try and explain how much something weighs. So if someone wanted to figure out how much grams I weigh, they have to weigh me or something. So I have to figure out how much the carbon monoxide weighs, which is in the unit grams. And I'm going to have to figure it out on periodic table because we don't know how much CO weighs. But there is 1 carbon, there's 1 oxygen. Oxygen weighs 16. Carbon weighs 12.01. I got these from the periodic table. I just kind of memorized like oxygen and carbon. 16 plus 12.01 equals 28. So I'm gonna put the 28 here because that's how much it weighs. Okay, last thing is finding the answer. So this isn't even the answer. We haven't even gotten to the answer. The answer is once you multiply these numbers divided by this. So I'm gonna times these numbers and then divided by 32. So it'll be 30 times 2 times 28 divided by 32. And then someone tell me the answer. Thirty times 2 times 28.01 divided by 32. And then I don't multiply by 1 or divide by 1 because if you multiply and divide by 1, it's the same number. So it's just a waste of time. And then the answer, which is going to be my theoretical, is going to be the one y'all calculate. So my theoretical is whatever someone gives me an answer. It is 52.52. 52.52. 52.52. 52.52 grams of CO. So everything that we just did is the theoretical yield. So that's like, this is what will actually come out if we did the experiment perfectly, because we went and did it from the equation. So obviously our reaction isn't going to be exactly the same as what we just calculated because it's going to be the actual. Select. Let me go back to. Okay, so this is what we were doing. So we planned it out. We calculated they gave us grams of oxygen. We wanted to figure out grams of carbon monoxide at the theoretical, so we had to calculate it. And then we figured it out, and it was 52.5. And then we will have to calculate percent yield. So we will use the one that they gave us, which is 40 grams, divided by 52.5 times 100. And then the answer would have been 76.2%. So I know this is it's just very tedious work. It's a lot of work. I'm not gonna lie, it's a lot. But that's it. So what we're gonna do is we're gonna do number 2 on the homework. So go to 7.4 homework, question number 2. And once someone tells me that they're ready, we'll start. 7.4 homework, question number 2. And I'm gonna turn off my camera because once I get really close, I look kind of dumb on the camera. it looks dumb. So I want to write it good because if I'm too close to the camera, I'm gonna look dumb and then I can't even write good if I don't do it like on tablet mode. So I'm gonna do it on tablet mode. Once someone tells me they're ready, we'll say. Legate is ready. So once Legate's ready, so we're gonna start. Okay. Number 2, it says 12.5 grams of copper. I'm just gonna label everything. It's good to label because then you might forget what's going on. Sometimes I forget. We're having technical difficulties with my pen. No. It says 12.5 grams of copper are reacted with an excess of chlorine gas, and 25 grams of copper chloride are obtained. Calculate the theoretical yield and the percent yield. Okay, so they want us to calculate theoretical and percent yield. Which number are we going to use? Are we going to use 12.5 or are we going to use the 25.4? So this is our reactant. And then this is our product. Which number are we going to use? The 12.5, correct answer. So that is going to be my given, and I write it in the first box. This 25.4 is my actual yield. So that's going to be my actual yield. So I will write it over there. Because we did the experiment and we obtained 25.4 copper chloride. So that's the actual yield. And then everything else, we're going to have to figure it out. So I have grams of copper. I'm going to have to put that in the bottom. And then once I put it in the bottom, it cancels out. But I have to find the mass of copper. And they didn't give it to me. So I'm going to have to find the molar mass. Where would I find the mass of copper? I don't have it with me. The unit for molar mass is grams divided by mole. I don't have the grams of copper. Where would I find the molar mass of copper? The periodic table. Very good. So I am gonna go to my handy dandy periodic table, and the mass of copper is 63.54. So if I went to the periodic table, I looked up what copper is. Copper is atomic number 29 with a mass of 63.54. Okay. So what do you guys think I'm gonna put on top? Here, in the stars. One more. So whenever I'm talking about molar mass, I put not a star, one more. Okay, 1 mole of copper. Okay. After that, I have to cancel out this mole of copper, so I'm gonna put it down here. Because if I divide it, this line means divide, it will cancel out. But next, I already used my molar mass, so now I'm talking about mole ratio. What is going to be the mole ratio of copper? In mole ratio, we get it from the coefficient, which are the big numbers in the formula. Where's going to be the coefficient of copper? And if there is no number, it equals 1. It's 1. If there is no number, it equals 1. It's an imaginary one. Because the element itself is 1. Next, I'm gonna put moles of copper chloride because that is where I'm trying to go to. That's my objective. So there is 1 mole of copper chloride. Okay. Next, I gotta cancel this mole of copper chloride, so I have to divide it, put it in the bottom. And then I'm solving for grams of copper chloride. So I'm gonna put it on top. So this is the unit of molar mass. Grams divided by mole. What am I going to put here? In where I drew the circle, the green circle. What am I gonna put in the green circle? Here. 1. Very good. And then I have to find the grams of copper chloride. I cannot use this 25.4. I can't. This is non-existent. We don't use that. So what I'm gonna do is I'm gonna have to find it on the periodic table. The mass of copper is 63.54. And this is the mass of copper. And then I'm gonna have to find the mass of chloride. But we have 2 in the formula. The mass of chloride is 35.45. Times those together, add them. I get 70.9 plus 63.54. And then when I add them together, what would I get? It's a pretty big number. It's not that big of a number, but let me check. Oh, I remember. I don't remember. I'll give you guys the answer. It's 134.44. So that answer, I will put it here. And then the last thing we gotta do is multiply. So I'm gonna multiply all of these divided by this. Because these lines means multiply. Multiply, divided by once we go to the bottom. Okay. And then that will give us the theoretical yield. So it'll be 12.5 times 134.44 divided by 63.54. And someone told me the answer. Don't have to. Anyone answer? Let me flip this up because we're done with that writing. Let me tell you guys how to put it in there. It'll be about a Newton, and then it wasn't even the right one. I wasted a bunch of money for no reason. 12.5 times 134.44 divided by 63.54. So that's the way you will put it in calculator. 12.5. Yeah, that's the correct answer. 26 point. Wait, what would you get? 26.45. Okay, so that's a theoretical yield, but that's not even. So we answered one part. We got that. Now we gotta do the percent yield. Percent yield is actual divided by theoretical times 100. So it's gonna be these two numbers divided by times 100. And then I'll get the answer. Because it's already set up the way it's supposed to. You just gotta times it by 100. And then it will be a pretty good yield. Pretty accurate. Whoever did the experiment did really good. They didn't do much, didn't mess up too much. 25.4 divided by 26.45 times 100. I was like, what's going on today? And tell me what you guys get for the yield, percent yield. What you guys count? Anyone get the percent yield? 25.4 divided by 26.45 times 100. My back hurts. I feel like such an old person nowadays. No, that's not the answer. Where am I getting these numbers from? 25.4 divided by 26.45 times 100. Those are not the correct answers. We got two people that answered. Both of them are not correct. Anyone want to give it a try? Yeah, that's the correct answer. Yeah, that's the right. Yeah. The answer is 96%. So that will be the answer for percent yield. 25.4? 25.0. So this is what you're gonna have to do for number 3 and number 4. But for number 3, they gave you the molar mass. So the molar mass is the weight of the compound. They already gave you that, so you don't have to calculate it. You just have to set it up, right? But for number 4, you will have to calculate molar mass. And number 1, it's completely different. Super easy. Number 1, I don't really think people need help on that unless you weren't paying attention. But that is safe to say. Let me stop it.